Hi everyone, welcome back to the channel. A few months ago, we deployed a new version to production. Pods were restarted normally and dashboards were green. And yet, users start reporting random request failure during deployment. We were confident that graceful shutdown was enabled, but in reality, it was not graceful at all. In this video, I'll explain what graceful shutdown actually means, what went wrong in production, why Spring Boot drops requests during deployment, and the exact production ready fix that solved this issue for us. So, graceful shutdown means stop accepting new requests, let in-flight request finish, close resources safely, then shut down the application. I'll explain this with the diagram. So we have load balancer and Spring Boot app running. Spring Boot is accepting the incoming request. So if receives termination signal from the app, so it needs to stop accepting new request, finish in-flight requests, and then ready for terminate. Now let's understand what actually happened in production. In production, when Kubernetes sent a SIGTERM signal to the pod entered in the termination state. But the load balancer was still routing traffic and Spring Boot shut down immediately. So all those in-flight requests were killed in the middle of execution. That's the main reason why users saw random 502 errors, especially during the deployments. Let's walk through the root cause step by step. So two major problems encountered. First was graceful shutdown was not enabled. By default, Spring Boot does not wait for request to finish. So if pod receives termination signal, then the incoming or in-flight request will get automatically killed. And the second one, no readiness probe was set up. The pod was terminating, but Kubernetes had no signal to stop routing traffic. I'll explain now what was the production fix that we did and how we verified the fix. So we enable graceful shutdown in Spring Boot. So by updating the application YML, server shut down graceful. And we set up the lifecycle timeout per shutdown phase, which is 30 seconds. So if pod receives termination signal, so it will wait 30 seconds so that in-flight request will get completed. This tells Spring Boot to wait for ongoing request to complete. And we also set up Kubernetes termination time, which will be greater than the Spring Boot shutdown timeout. And the third one is proper readiness probe. So we set up readiness and liveness probe. So if this is not healthy and the pod is not healthy, then it will not receive new incoming requests. We verified the fix by sending long running requests, by triggering deployment multiple times, and watching all in flight requests finish successfully or not through monitoring logs and dashboards and confirming zero drop requests during the rollout. If you deploy Spring Boot application to production, this setup is not optional. If this video helped you, do like and subscribe. On this channel, we focus on real failures, real systems, and real engineering decisions. Thanks for watching.